Okay, let's look at some applications for exponential functions. The reason why we need to use exponential functions is because not everything in the world can be defined with just a polynomial. So we're not just going to use x squared and all that. We need more than that to be able to interpret the world around us. So one of the applications is something called compound interest. So this is if you ever put money in the bank and you put it in a savings account that earns interest, this is what's going to happen. Okay, when people are investing money, this is what they use, compound interest. So there are two kinds. There's two equations, and we'll talk about what all of the variables mean. The first one is A equals P times 1 plus R over N to the N times T. So that makes it exponential because we have a number, we have a variable in the exponent. So that's exponential. Okay. There's another case that's also compound interest, but here it's A equals P times E to the RT. Okay. So these things. A is interest plus principal. Okay, so these are kind of some crazy words, but all it means is principal is what you initially deposit, and interest is what you earn. So money just sitting in that account will earn money. It'll earn interest. And so when you add those together, you get your total money. So this is kind of like what you end up with at the end of the day. So principal, we've already kind of talked about. The P stands for principal. It's what you start with. Or you could also think about it as like an initial deposit. Okay. The next thing is we have R. So R is the rate as a decimal. It's usually given as a percent. So if they told us that it was 5%, so percent is out of 100, so that means the decimal moves twice. So our decimal there would be 0.05. So be careful there that in both of these equations, the rate is used as a decimal, because you'll hear like, okay, this savings account earns 5% interest, or sometimes with credit cards you have to pay 5% interest. So that's what that's talking about. Then the next one is N. Number of times compounded in a year. So whenever we have that information, we can use this first equation. This first equation is just talking about compound interest in times a year. So if they said annually, then it would be 1 time a year. If they said anything else, biannually, twice a year, quarterly, 4 times a year. So depending on if they're talking about a certain number of times a year, that's what they're talking about. And then lastly, we have the number of years. So if we're talking about 1 year, then, and it happens once a year, then over 2 years, it would happen twice, okay? So all of these variables go into this first equation. And then we have this equation over here is continuous. So whenever they're asking for continuous compound interest, that's when you would move to this equation. These two equations, you're going to be given the equation, okay? We need to know how to use them, but in a calculus problem, they're going to give it to you. You do not have to memorize these compound interest equations. That would be nuts, okay? So I want to look at one problem that kind of encompasses everything. So on this next slide, take a second to write down this equation. So I moved the equations over there. I mean, take a second to write down the problem. So it is a word problem. I'm going to type it out and then you can write it down. Okay, so we are looking at this problem. It says a deposit of $2,500 is made in an account that pays an annual interest rate of 5%. Find the balance in the account at the end of 5 years if the interest rate is compounded, A, quarterly, B, monthly, C, continuously. Okay, so let's look at these three cases. Well, the first two give us a set amount in a year. So A and B, we are going to use this first equation, and then continuously, we're going to use this second equation. Okay, so A, quarterly. Well, that means that how many times a year does that happen? Quarterly, that's into 4 parts, 4 quarters. So N is 4 times a year. Okay, they ask us to look at a rate of 5%. So our rate is 5%, but remember the rates that we use are always decimal. So that's 0.05 is actually the number that we're going to use. Then initial deposit, so that's our principal, is $2,500. And they're asking us to look at the end of 5 years. So the time that we're looking at is 5 years. So let's plug all of this information in. To figure out our final amount, we are looking at P. So P is 2,500 times 1 plus the rate is 0.05 divided by the number of times of year, which is 4. All to the 4 times t, which is 5. Okay, so plug all that in your calculator, and you'll get about, you'll get a longer decimal, but this is money. So this is not 3 decimal places. We measure money with 2 decimal places. So this is 3205.09. Okay, and then let's look at the second one. If we're thinking monthly, that means in this time there's 12 months in a year. Our rate is the same. The principal has not changed. The time has not changed either. So here we are finding A. We need the principal, so P is still 2,500. 1 plus our rate has not changed, but how many times a year has? So this is divided by 12, and this is 12 times 5. Plug that into your calculator, you'll get a crazy decimal, but remember this is money. So this is 3208.40 is the answer there. And then look at part C, continuously. So continuously is the new equation, A equals PE to the RT. A equals PE to the RT. So E is already a number, remember. So if we want A, it's P, which is 2,500, times E, and then we have R, so our rate is 0.05. Times T, they're asking us to look over 5 years. So we can put this in our calculator. Again, you get a crazy decimal, but this is money. So 3,210 and 6 cents when you round that correctly. So be careful there, you do have to round correctly. And then the last thing that you will need to know for the homework is if they asked us, so if they gave us an equation, and then they asked us for the rate at which it changes. So say, let's take this A equals PERT. And say they gave us an initial, or maybe they didn't give us an initial deposit, but they gave us, so it was still P, and then E, the rate, they gave us a rate, so maybe it's 2%, 0.2, and the time, they didn't tell us the time. They didn't tell us how long, how many years are we looking at. They just kind of give us a general idea. Well, if they asked us for the rate at which this changes, remember that's talking about derivative. So if they've given us an equation like that, what we need to do is take the derivative of this. So dA, and our variable here is dt. Well, P is just a number. We don't know what that number is, but it is just a number. They told us that there is going to be an initial deposit. So that's what we're going, so P is just a number out front, so it's going to continue just to be a number out front. We don't need to do the product rule. But we do need to take the derivative of e to the 0.02t. Well, that's going to be e to the 0.02t. And then I need to multiply by the derivative of the exponent. So here our exponent is 0.02t. So the derivative is 0.02. So if they asked us for an equation for the rate, we would say that it's 0.02 PE to the 0.02 T. Okay, so if they ask us for a rate, we are taking the derivative. And then they might ask you to like plug some time in or a principal or anything like that. They might ask you some questions about that. But just keep in mind, remember, rate of change is always taking the derivative.